Hey guys, tonight we step into the shadowy origins of human ingenuity. Imagine dusty torchlight dancing on jagged cave walls, and you probably won't survive this journey. Just kidding, but seriously, the past can be brutal. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, post your location and local time in the comments so we can see who's up at this hour. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge into a dim cavern, the crunch underfoot echoing in your skull like a distant drum. Your flashlight halo reveals a rickety wooden shelf hewn from ancient timber upon which lie stone tools so precise they might have been cut by laser. Mainstream historians tell us that Homo erectus first crafted hand axes around 1.76 million years ago at West Turkana, but these specimens seem to mock that timeline. Historians still argue whether early humans possessed the cognitive leap to conceive such fine geometry or simply stumbled into it by sheer luck. Your fingers brush against an obsidian blade so thin it flexes like a butterfly wing, yet shatters glass in a single swipe. It's a fringe tidbit that some enthusiasts whisper could prehistoric craftsmen have employed sonic resonance drills, using humming reeds to vibrate stone. You chuckle softly. If only your high school chemistry teacher could see you now experimenting with rock karaoke. No pop quizzes here. Unless you count my unsolicited trivia, this obsidian likely traveled hundreds of miles via ancient trade routes, a testament to long-distance exchange networks. As you move deeper, you encounter a set of polished bone chisels laid out like surgical instruments. Their symmetry rivals modern CNC tools, inviting the cheeky thought that your grandfather's workshop lathe might feel jealous. One tool bears tiny spiral grooves. Mainstream archaeologists believe they're simply for grip, yet some fringe researchers argue they're evidence of craftsmanship, techniques lost to time. Historians still argue whether those grooves were carved with stone drills or bone awls wrapped in sinew. You shrug, wondering if your next DIY project should borrow a page from the Stone Age. A low rumble pulses through the cave floor, reminding you of ancient seismic activity, and you recall the great irony that our ancestors might have been the first to notice plate tectonics long before scientists formalized the theory. Tiny fragments of iron-bound wood hint at primitive water-driven machinery, suggesting they harnessed river currents to power drills or grain mills. You might not survive this cavern's humidity if you brought your Sunday best, but at least you'd look archaeologically good. Suddenly your beam catches a copper-tipped awl, its patina still gleaming emerald in the half-light. Mainstream fact, early metallurgy in the Balkans dates to around 5500 BCE, but this tool seems eerily advanced, as if someone fast-forwarded human technology by centuries. A quirky rumor persists that secretive metal workers encoded messages in their alloy recipes, perhaps a prehistoric morning logbook. Historians still argue whether such codes existed or are just fanciful modern projections. You smirk, imagining dusty alchemists complaining about rust on their coffee mugs. You pause at a set of miniature bronze gears, no larger than a thumbnail, interlocked in a fractal pattern. Mechanical precision of this scale doesn't appear in documented history until medieval clockmakers. Yet here it is, in a prehistoric context. Some enthusiasts claim these are relics of a lost automaton workshop dozens of millennia ahead of its time. Historians still argue whether these gears belong to ritual objects or functional machinery. Either way, you're tempted to pocket one, though TSA probably wouldn't appreciate your souvenir. A chill wind snakes through the chamber, carrying the scent of damp earth and mystery. You remember that crocodile dung sunscreen from last week's video? Don't worry, there's none here, but the pungent aroma of ancient oils lingers. You run a finger along a carved groove, marveling at its perfect semicircle. Fringe minds speculate about sound wave fracturing a technique so advanced that NASA might want to audit their protocols. You giggle at the thought, moon-bound rockets, powered by Stone Age tech, what a crossover event. As you near the cavern mouth, your heart pounds with excitement and a tingle of disbelief. These tools born in the shadows of prehistory challenge everything you thought you knew about human progress. They're rough, they're raw, and yet they gleam with an otherworldly precision that rivals modern lab equipment. You brush off a speck of dust, step back into the night air, and let the cool breeze wash away the claustrophobia. You blink under the open sky, chest heaving with exhilaration. Ahead lies a world that feels both familiar and impossibly advanced, a reminder that sometimes the past surpasses the present in ways we never imagined. Don't worry, I won't quiz you on prehistoric power tools unless you count your next comment as extra credit. You crouch low beneath a jagged overhang, the cool stone pressing into your knee like a reluctant guest on a sofa, and run your fingertip across a series of parallel grooves that shimmer in the beam of your headlamp. Mainstream archaeology tells us that humans first crafted engraved ochre pieces at Blombos Cave in South Africa around 75,000 years ago, carving crosshatch patterns into pigment-rich rocks. Historians still argue whether these early designs held symbolic meaning or were mere doodles. But these grooves before you aren't ochre. They're incised directly into granite with astonishing uniformity, as if a laser once traced each line with digital precision. A musty scent of stone dust and ancient air tickles your nostrils, while distant drips echo like a slow metronome. You lean in closer, noticing the cut depth never varies by more than a hair's breadth. Fringe enthusiasts whisper about sonic resonance carving, using hollow bone tubes to amplify chanting and fracture stone along predetermined lines. You stifle a yawn as you imagine your college choir rehearsing Bohemian Rhapsody to chisel statues. Talk about hitting the high note. Your flashlight picks out tiny cross-sections where the grooves intersect at perfect 90-degree angles. Someone joked that these look like prehistoric QR codes. Scan here for cave person TikToks. Yet here you are standing in a subterranean gallery, thousands of years older than the wheel, contemplating if prehistoric engineers knew more about geometric optics than your old geometry teacher ever did. Historians still argue whether these engravings were utilitarian tools for measuring length or covert celestial maps tracking solstice shadows. You brush away a flake of mica, its reflective sheen glinting like a disco ball, fragment revealing a faint spiral etched beside the straight lines. Mainstream fact, Paleolithic peoples used natural pigments and carved bone tools, but spiral motifs usually appear on pottery from the Neolithic period around 9000 BCE. Here they sit on hard stone defying timelines by millennia. You feel a tingle of excitement mixed with a smidge of imposter syndrome. Your last pottery class ended in lopsided bowls and clay in your hair. In the beam's periphery, you catch a glimpse of a shallow basin carved into the floor, its channel leading toward a tiny central depression. Fringe theorists propose it's an ancient fluidic leveling device. Fill the grooves with water and watch it flow evenly to calibrate temple foundations. You can almost hear a toga-clad architect whispering, "By Zeus, my columns are plumb." You chuckle. If only your spirit animal archaeologist had brought waterproof boots. The sight of a perfectly straight groove stretching across a curved surface makes you pause. You tap your headlamp twice. Maybe it's low battery hallucinations. But no, the edge is razor sharp, capable of slicing through the woven fibers without snagging. Mainstream archaeologists have found beads threaded on sinew dating back 40,000 years. But here's a cutting tool unmatched until Industrial Revolution milling machines. Historians still argue whether the ancients developed bronze saws far earlier than recorded, or if this is a unique regional anomaly. You crouch and snap a photo with your phone. Autofocus struggles, but finally locks onto the fine edge. Modern engineers would drool over this craftsmanship. You imagine sending it to your mechanically inclined cousin who collects vintage power tools. He'd trade you his 1950s lathe for a shot at reverse engineering these grooves. You suppress the urge to post on Instagram. No hashtags allowed in these sacred halls. Wind gusts through a narrow shaft carrying whispers of past visitors and the faint tinkle of your car keys dangling at your hip. You peer at the adjacent wall, which bears concentric circles that converge toward a single focal point. Fringe rumor holds that ancient artisans used magnifying crystals, perhaps mica sheets polished into lenses, to focus sunlight and scorch stone surfaces. You grin at the thought. Prehistoric sunburn now, that's a throwback. As you stand, you catch a whiff of damp earth and recall that popular theory places the origin of the first cave art at Chauvet Cave in France around 32,000 years ago, where animal silhouettes emerge from darkness. But these laser-like cuts bear no pictorial art, only abstract precision, suggesting a purpose beyond decoration. Historians still argue whether the grooves functioned as low-tech sundials marking solar angles, or as part of a ritual performance under flickering torchlight. Your stomach rumbles time for a snack break. You rummage in your pack for granola and find a half-crushed chocolate bar. The aroma of cocoa mingles with the mineral tang of the stone floor. You take a bite and savor the contradiction. Is there anything more 21st century than chocolate in a Stone Age grotto? You pause, reflect on how human innovation spans food and tools alike, and how you're blissfully combining both. Resuming your exploration, you notice tool marks along the edges, microscopic striations that align with the main grooves. Mainstream studies of Paleolithic tool use mention microflaking techniques around 20,000 years ago, yet these marks are too uniform to be accidental. It's like finding your grandmother's antique sewing machine in a prehistoric toolkit, utterly unexpected. You rub your chin, wondering if these artisans hoarded secret blueprints passed down through generations in oral code. A beam of sunlight pierces an opening above, illuminating dust motes, dancing like tiny fireflies in a low-gravity ballet. You tilt your head back, blinking title screen style, and wonder if this was designed to align with midday sun on equinoxes. Fringe groups contend it's an astronomical sighting platform forecasting seasonal floods. You press your palm to the engraved furrow, feeling its cool consistency and anchoring your mind to the whispers of history. Your mind drifts to the rhythmic chant of those sonic resonance drills, imagining ancient engineers humming in unison as they carved granite to shimmering perfection. You shake your head, half amused, half in awe. These grooves challenge everything you learned in grad school lectures about primitive toolkits. And yet here they are, silent testimony to human curiosity and daring experimentation long before modern labs existed. You step back, surveying the chamber with renewed wonder, every straight line and spiral symbol whispering secrets you might never fully decode. The cave feels alive, as if the stone itself breathes under your gaze. You carefully retrace your path toward the exit, leaving the laser-like engravings to their eternal vigil. Outside, cool night air brushes your face, and you exhale a slow breath, heart still thrumming with excitement. You check your watch, local time, post-midnight. Only the bravest or sleep-deprived would venture here at such an hour. You tuck your phone away, smile at the sky, and wonder what tomorrow's excavation will reveal. You cradle the Antikythera mechanism in your gloved hands, its corroded bronze gears, whispering tales of ancient ingenuity, and you probably won't survive dropping it. Just kidding, but seriously, it's delicate. Mainstream historians tell us that this marvel, dredged from a 1st century BCE shipwreck off the coast of Greece in 1901, is the world's oldest known analog computer, capable of predicting eclipses and planetary positions with surprising accuracy. Historians still argue whether similar devices existed centuries earlier or if this was a singular genius invention. The device's circular dial unfolds before you like a celestial roadmap, concentric rings engraved with Greek inscriptions that chart the movements of the sun, moon, and even the then-known 5 planets. You trace a finger over a tiny pinion wheel. Mainstream fact: it's estimated to contain at least 30 interlocking gears, some with a tooth count so precise that modern machinists marvel at the ancient craftsmanship. Fringe enthusiasts whisper that Archimedes himself may have designed the blueprint, or that Pythagorean school mystics encoded gematria codes into the gear ratios to unlock cosmic secrets. You let out a soft chuckle, imagining toga-clad scholars arguing over a 30-tooth wheel. By Zeus, this ratio is off by 1 tooth. Must be a divine prank. You tap the mechanism gingerly and it ticks faintly as if awakening from a 2 millennia slumber. A memory flickers. Last section, you joked about prehistoric QR codes. This time you're handling an actual analog calculator that predates your smartphone by over 2,000 years. The absurdity makes your eyelids droop just a little, a perfect mix of awe and bedtime sedation. As you rotate the main crank, miniature gears engage and the pointer hands shift across broken dials. You imagine ancient mariners using this to steer by star charts, chart tidal patterns, and plan holy festivals, tasks that now rely on satellites and quantum chips. Fringe theory posits that the Romans used a modified version to schedule chariot races in the Circus Maximus, complete with sunrise to sunset lap predictions. Historians still argue whether such adaptations ever left the workshop of Greek artisans or stayed prototypes in a coastal shrine. Your flashlight beam glints off a corroded fragment, a tiny gear tooth etched with an almost microscopic delta symbol. You lean closer, half asleep, thinking maybe it's a sign to offer more goats' blood sacrifices to the gear gods. In reality, the tooth count was so precise that it required high-quality bronze alloy, casting, and lathe-like tools. Mainstream metallurgical analysis dates its construction between 150 and 100 BCE. You stifle a yawn, picturing ancient metallurgists complaining about impurities. Ugh, these casting bubbles, back to the foundry again. You recall the polished bone chisels from section 1 and the laser-like grooves in section 2. And here's another callback: precision tools transcending time. It's as if history has a secret playlist of engineering hacks and you're streaming every track. You can't help but imagine an ancient workshop where artisans jammed to wind whistle tunes while soldering brass, an ASMR remix of clinks and clanks echoing off stone walls. The dial's outer ring bears zodiac signs, each image painstakingly engraved. You squint, blinking twice. Maybe it's the fan breeze lulling you to sleep, or maybe it's the gentle swirl of constellations whispering cosmic lullabies. Mainstream astronomy notes that Hellenistic scholars mapped zodiac constellations as early as the 5th century BCE, but this device translates that knowledge into mechanical motion. Fringe tales claim this was part of a lost school of cosmic mechanics, teaching initiates to drive the stars like ancient Uber drivers for the gods. Historians still argue whether the inscriptions follow Babylonian prototypes or represent an original Greek synthesis. You spin the pointer until it aligns with a tiny aperture showing the moon's phase, watching a silver-toned disk rotate to reveal a crescent. It's mesmerizing so much so that you almost forget you brought a packet of trail mix. You shake yourself awake, rummage for a handful of nuts, and let the salty crunch echo through the silent lab. It's a strangely modern snack in an antique setting, proof that some comforts never change. In a recessed compartment, you find a fragment of ivory, perhaps once at a pointer handle, engraved with tally marks. Mainstream conservationists warn that ivory use peaked in the Roman era, fueling elephant hunts. Here, though, it served a high-tech purpose. Fringe speculation argues that itinerant engineers carved ivory into calibration keys, each tally marking successful eclipse predictions. You imagine a disgruntled apprentice scratching marks after every missed forecast. 2 more solar eclipses and I'm out of here. An ASMR-worthy click echoes as you engage a secondary gear train, causing the planetary indicators to whir in tiny bursts. You lean back against the velvet cushion provided by your over-prepared guide and close your eyes for a second, hearing only echoes of dripping lab water and the mechanism's ghostly ticking. It's like a lullaby engineered by centuries of human curiosity, louder than any lullaby app you've downloaded. You catch yourself nodding off mid-analysis, must be that soft narration in your head. You lift your eyelids to see the device's remains hunched over display pedestals lit from below like relics in a museum diorama. Mainstream restoration began in the 1950s, but only in recent decades have researchers used X-ray tomography to reveal hidden gear trains. Historians still argue whether those hidden wheels powered an eclipse predictor or served more esoteric ritual calendars. You tap your temple, recalling that crocodile dung sunscreen joke. At least this mechanism is cleaner. The fan's quiet hum mingles with your breathing, and you feel a pleasant drowsiness crawl in. Yet before you drift fully, you slide a tiny LED flashlight, your modern homage, into a gap to illuminate the 223-tooth spiral gear known as the Saros cycle gear, predicting eclipse recurrence every 18 years, 11 days. It's a cosmic alarm clock except without snooze, so perhaps not ideal for waking up on Monday. You let the mechanism rest on its velvet cradle and stand legs a bit stiff from crouching. The room's hush feels sacred, as if any sound might shatter this fragile link to our Hellenistic ancestors. You imagine the device's final voyage, its ship-foundered treasures lost to the deep, until fishermen hauled it centuries later, oblivious to its astronomical brilliance. Stepping toward the exit, you glance back one last time, picturing ancient hands, assembling tiny gears under oil lamps, guided by star charts and maybe a glass of watered-down wine. You smile at the thought of those Hellenistic engineers, their dedication echoing through time in every meticulously cut tooth and engraved dial. You slip out of the lab into the corridor cool air, greeting your face as if world itself exhales along with you. Outside, the night sky wheeling overhead feels intimately familiar, because the mechanism you've just held once turned those very stars into moving hands on bronze. You check the clock on your phone, local time, 1:14 a.m., and decide it's bedtime material. No quizzes tonight, just me, you, and a ticking bronze lullaby. You step into the hushed corridor of the Great Pyramid, the heat from the limestone walls pressing against your skin like a warm blanket you never asked for, and you probably won't survive getting sand in your socks. Just kidding. But seriously, those grains are relentless. You run your fingers along the worn grooves in the polished casing stones, catching the faint scent of ancient mortar and camel sweat. Historians still argue whether the core blocks were lifted via external ramps or an internal spiral ramp hidden from plain sight. Mainstream archaeology dates the completion of the Great Pyramid of Giza to around 2560 BCE, built for Pharaoh Khufu, standing nearly 480 feet tall, remarkably precise, for a civilization without cranes or forklifts. You squint at the massive blocks, each weighing up to 15 tons, stacked so evenly that your fingernail couldn't slip between them. The straight edges mock your budget DIY bookshelf that wobbles at 3 books high. In the dim glow of your headlamp, you spot hollows in the wall that hint at plugged shafts, perhaps part of an ingenious counterweight system. Fringe theorists whisper about water-powered hydraulic lifts buried behind those stones, using Nile floodwaters to float massive platforms. You imagine ancient Egyptian engineers in linen kilts grumbling, "Where did I leave my damn blueprint?" And you stifle a chuckle, picturing them logging into early Google Docs. As you round a corner, Your foot nudges a triangular block with chisel marks so uniform they could have been cut by a diamond-tipped saw. Mainstream fact: archaeologists have found copper chisels and dolerite pounding stones at quarry sites near Aswan, showing the tools they likely used. Yet the tiny spiral patterns on this block seem too precise, as if they followed digital blueprints. Historians still argue whether those microgrooves resulted from natural weathering or deliberate smoothing by lost polishing machines. A faint breeze carries the earthy aroma of limestone dust and the sweet undertone of date wine from a nearby offering niche. You take a sip from your water bottle. Modern refreshments never tasted so exotic. You lean in to inspect a niche where a wooden lever once fit. The uneven wear suggests repeated mechanical action. Fringe enthusiasts claim these were sockets for pivoting poles, allowing workers to hoist blocks by rocking them upward like ancient seesaws. You smirk at the thought of thousands of laborers taking turns on a giant seesaw workplace. Morale must have been shifty. Your light bounces off a small cavity leading to a narrow tunnel you hadn't noticed before. It slopes gently upward, curving around the pyramid's core, supporting the internal ramp theory by architect Jean-Pierre Houdin. Mainstream surveyors using infrared thermography have detected density anomalies consistent with such a tunnel, yet scholars still argue whether that's an original feature or a later structural weakness. You press your palm against the smooth limestone, feeling the millennia-old vibrations. It's like high-fiving history itself, minus the sticky palms. You pause to scratch your chin, recalling the Antikythera mechanism's gears from Section 3 and the laser-like prehistoric grooves of Section 2. This pyramid seems part of the same secret playlist of remarkable engineering feats. The thin line connecting ancient Greece's clockwork to Egypt's stonework feels like time-traveling through an engineering conference you missed. You can almost hear the keynote innovations through the ages, from obsidian lasers to limestone elevators. A sudden drip echoes through the tunnel water, seepage from the Nile's high tides, millions of years ago maybe. The sound reminds you of a leaky faucet your landlord never fixed. You shuffle forward, the tunnel narrowing until you duck under a low lintel into a small chamber. Here the ceiling stones align at a slight angle, suggesting they were pried into place rather than dropped. Mainstream Egyptologists note that the precision of these alignments is within 1/100th of an inch, rivaling modern engineering tolerances. Historians still argue whether they used simple plumb bobs or more sophisticated spirit levels filled with animal fat. You lean back against the wall, legs itching from the uneven floor. The silence is broken only by your breathing and the distant drip. You recall the crocodile dung sunscreen joke from Section 1. No gooey ointments here, thankfully. Instead, you rub your arms, feeling goosebumps. Despite the desert heat, cave air chills you more than you'd expect. A faint glow filters through a tiny opening ahead, hinting at another passage. Before moving on, you inspect a cluster of small indentations in the wall, each the diameter of a palm. Fringe speculation holds these were alignment markers guiding laser-like sightlines, using polished obsidian mirrors to track true north. You laugh at the mental image, ancient surveyors squinting through obsidian spyglasses whispering, "Okay team, don't move that laser." You slip a notebook from your pocket and sketch the indentations, adding a doodle of an Egyptian engineer wearing a headlamp and high-visibility vest, anachronistic, but you can't help it. Your doodles have become a running joke. When in doubt, add modern safety gear. You jot the note, investigate if safety vests were buried with workers as a morale booster. Pushing onward, you enter the Queen's Chamber replica section, parallel tunnels constructed to study acoustics. You clap your hands. The sound reverberates in haunting echoes. Mainstream experiments show the chamber's resonance matches human vocal frequencies, suggesting ritualistic singing took place here. Historians still argue whether these echoes were intentional design for sacred chant or incidental byproduct of block placement. You hum a soft tune, imagining priests serenading the pharaoh's granite sarcophagus like a cosmic karaoke night. The chant-like echo lulls you into near drowsiness. ASMR meets archaeology, yet you press on toward the grand gallery. Its towering walls converge above you like the hull of an upturned ship. You notice grooves along the floor track, likely used to guide the massive granite beams. Fringe lore speaks of anti-gravity crystals embedded in the stones, reducing effective weight by channeling Earth's magnetic field. You roll your eyes affectionately at the crystal theory, but if crystals could cut granite, your jewelry box might hold the secrets to aerospace engineering. As you climb the gentle incline of the gallery, your foot brushes a narrow channel carved into the wall, perfect for holding lubricating water to reduce friction on sledges. Mainstream reliefs depict workers pouring water in front of moving statues, so the idea has visual backing. Yet some fringe voices argue that ancient Egyptians used acidic plant extracts to further dissolve surface friction effectively, stone Teflon. You chuckle at the image of pharaohs ordering squeegees and stone-off spray for inventory day. You emerge into the open sunlight, your silhouette framed by the pyramid's massive stone face. The desert breeze whips across your skin, carrying dust motes that glint like golden confetti. You pause, shading your eyes, and take in the towering monument, its geometry still flawless after 400 or 500 years. It feels like standing before time's greatest handshake. Your watch reads 2:28 a.m., definitely past bedtime for mere mortals. You tuck away your notebook and water bottle, feeling the cool night air on your flushed cheeks. These internal passageways, counterweights, and possible ramps may never yield all their secrets, but they whisper of a lost toolkit of wonders. You step back onto solid ground, heart pounding with a thrill of discovery and the comfort of knowing your bed awaits. You dip your hand into a tide-lapped Roman breakwater, the water sloshing around your wrist like a lazy wave at sunset, and you probably won't survive stepping on those barnacles barefoot. Just kidding, but your feet will remember the sting. Mainstream fact: Roman engineers perfected concrete as early as the 2nd century BCE by mixing lime with volcanic ash. Pozzolana, a recipe Vitruvius documented in his treatise, De Architectura, creating structures that have outlasted empires. Historians still argue whether this longevity was intentional engineering brilliance or fortunate trial and error. The harbour wall before you feels surprisingly smooth, its surface mottled with patches of ancient tufa and embedded seashells. You run your thumb over a section where mineral growth has filled microscopic cracks, a natural self-healing process modern scientists envy. Fringe whispers claim that Roman builders sometimes added donkey milk to their mortar, believing its proteins improved plasticity and cured cracks, a quirky notion that evokes visions of builders pouring milk jugs instead of water buckets. You stifle a sleepy chuckle, dairy-based concrete anyone. A gull squawks overhead, its cry echoing off centuries-old stones. You lean closer to inspect an exposed aggregate of crushed terracotta shards or cocciopesto, which enhanced water resistance in submerged structures. Mainstream engineers note that this crushed brick additive reacted chemically with seawater to form aluminous tobermorite crystals, bolstering the concrete's strength over millennia. Yet some fringe researchers argue these shards weren't waste recycled for convenience, but a secret ingredient handed down by temple priests to sanctify marine temples. Your stomach rumbles, reminding you of your granola bar tucked in your pocket. You tear it open, the granola clusters spilling like miniature ruins, and pop a handful into your mouth. The peanut butter-like flavor mingles with briny air as you crunch modern snacks at ancient sites, the best of both worlds. You wipe crumbs from your chin and imagine Roman workers grabbing figs and olives between pores of mortar, sweaty brows glistening under the Mediterranean sun. You pivot to examine a nearby arch pierced in the breakwater, its hollow core a testament to Roman mastery of form and function. Mainstream fact: the Pantheon's concrete dome, poured around 126 CE, remains the largest unreinforced concrete dome in the world, its thickness tapering from nearly 21 feet at the base to just 8 feet at the oculus to reduce weight. Historians still argue whether builders used coordinated scaffolding of wooden forms or innovative pressure-molded vaults to shape such complex curves. In the waning light, you notice a cluster of sponge fossils embedded in the concrete, their porous skeletons preserved like ghostly fingerprints. Fringe lore speculates that ancient engineers intentionally harvested sponge spicules for their silica content, hypothesizing an early form of biogenic reinforcement. You smirk at the thought: Roman biotech next-level collaboration between builder and barnacle. Who knew oysters and sponges doubled as structural aids? You recall the crocodile dung sunscreen gag from Section 1 and the laser-etched grooves from Section 2. This resilient concrete feels like the third track on the same ancient engineering mixtape. You trace a finger along a horizontal joint called a construction seam, where successive pores met each layer, blending seamlessly into the next. Mainstream studies show these seams are nearly invisible to the naked eye, pointing to highly controlled mixing and pouring techniques. Historians still argue whether mixers used water-powered mills for consistency or relied on manual paddleboards. A gentle swell nudges your legs as a wave slips under the arch. You watch the water draw back, revealing crystalline growths of zeolite minerals that form only through prolonged chemical reactions between volcanic ash and seawater. Fringe enthusiasts joke that Romans stumbled upon a prehistoric coral reef buried in mortar, joking that Poseidon himself whispered the recipe. You chuckle softly, imagining Poseidon cameoing as a subcontractor in toga and trident. Your flashlight picks out a small patch of graffiti etched centuries ago, a simple doodle of a ship with oars and a tally of Anno Divit year 507 in local reckoning. Someone scrawled it with a metal stylus, perhaps a bored soldier on winter duty. Mainstream epigraphy confirms that Roman sailors often marked their presence with inscriptions, leaving invaluable chronological clues for modern scholars. Historians still argue whether these marks indicate pride in engineering achievements or mere boredom during long deployments. You lean back on a dry stone ledge, sea breeze tousling your hair. The ASMR-like whisper of waves and rustle of gull wings lulls your eyelids. Yet you perk up at the sight of a small fissure filled with crystallized calcite, its veil of white crystals shimmering like opalized icing. Fringe theories propose that Romans used acidic plant extracts like fermented grape must to etch microchannels in their concrete, promoting crystal growth and sealing cracks. You raise an eyebrow: fermented concrete. Now that's a buzzword for modern material scientists. Crunching another granola bite, you remember the Antikythera gear train from Section 3 ticking away in your mind, and the internal pyramid ramps of Section 4 echoing in your memory. This Mediterranean masterpiece feels woven into the same tapestry of forgotten genius. You imagine an engineer sampling mortar with a wooden ladle, comparing color swatches like a homeowner choosing paint, but with stakes measured in centuries, not months. A gull circles overhead, its wings casting shadows across the weathered surface. You reach out to steady yourself, fingertips grazing the cold, salt-encrusted masonry. Mainstream conservationists use these surviving breakwaters to study sustainable building techniques, hoping to reverse engineer low-carbon concretes. Historians still argue whether we've lost more to time than we've gleaned from ruins. or if future generations will look back at our skyscrapers with equal puzzlement. You hear your own breathing sink with a gentle lap of the tide, a hypnotic duet that blurs the line between past and present. You tilt your head back, closing your eyes, letting the ambient sounds cradle you like a lullaby. The mixture of ancient mortar sea spray and a hint of donkey milk legend blends into a singular aroma, earthy, briny, and strangely comforting. When you finally open your eyes, dusk has deepened to twilight. The harbor lights across the water twinkle like phosphorescent relics. You slip off the breakwater, wiping your hands on your jeans, grit and salt mingling in the fabric. Your watch reads 3:33 a.m., definitely beyond reasonable bedtime. You turn for one last glance at the weathered concrete, marveling at its silent durability. No clever tooltips, no digital dashboards, just ancient science and volcanic ash doing their eternal work. You tuck your granola wrapper into your pocket for later waste, not want, and step onto the moonlit shore, heart full of wonder and eyelids heavy with sleep. You cradle the clay jar in your hands, its rough exterior warm from the desert sun, and you probably won't survive dropping it on your foot. Just kidding. But ouch, that hurt more than any Indiana Jones trap. This artifact, unearthed near Baghdad in 1936, is part of what scholars dub the Baghdad Battery, dated to around the Parthian era, circa 150 BCE 223 CE. Historians still argue whether these simple clay vessels were designed to generate electric currents or served as humble scroll holders. Your fingers trace the contours of the jar's neck, where a corroded copper cylinder nestles inside an iron rod. Mainstream fact metallurgical analysis confirms the copper and iron components date to the same period, suggesting intentional assembly rather than random debris. You inhale the earthy scent of baked clay and lingering desert dust, a sensory link to artisans who might have mixed materials for alchemical experiments. A gentle breeze rustles the palm fronds outside the dig tent, whispering through the canvas walls like a hushed incantation. You imagine ancient alchemists hunched over earthenware, muttering arcane formulas as they poured vinegar into jars, hoping for sparks. Fringe theorists propose they used these jars to electroplate gold onto silver jewelry, a quirky image of Parthian bling parties, where priests tested voltages before dazzling their congregation in gilded finery. You chuckle at the mental picture of toga-clad influencers flexing electroplated rings. Your headlamp's halo illuminates mineral encrustations inside the jar, green verdigris and rust mingling in abstract patterns. You lean in, squinting, half asleep, half entranced by the jar's patina. Mainstream archaeologists have found similar batteries across Mesopotamia and even in ancient Egyptian contexts, suggesting a wider experimental tradition. Historians still argue whether these devices were widespread tools for crafting religious icons or esoteric lab equipment used by secretive knowledge keepers. You shake off a stray yawn as you unscrew the jar's ceramic lid, revealing a pitch-black residue at the bottom. A whiff of fermented vinegar tickles your nostrils, reminding you of last night's dinner. At least here, the tang feels appropriately ancient. You dip a gloved finger into the vial and taste a faint sourness. If you ever get electrocuted by curiosity, at least you'll have a minty aftertaste. Across the table, your assistant holds a voltmeter wires, snaking from the battery's copper tube. You hear a soft click as the meter reads a few hundred millivolts, not enough to power a light bulb, but certainly enough to tingle the fringe theories. You recall the laser-etched stone grooves from Section 2 and the Antikythera's ticking gears in Section 3. This jar feels like the next track on that ancient mixtape of technological marvels. You slip a small LED probe inside the cylinder. It flickers weakly like a nightclub where only 2 patrons showed up. You smirk. Everyone wants to light up a disco ball with Parthian batteries. Historians still argue whether the original jars held acidic plant juices instead of vinegar, boosting current through organic acids. Imagine ancient chemists squeezing pomegranates for power. A low hum from the tent's portable fan reminds you of ASMR videos as you whisper, "Imagine the first spark like a prehistoric firefly winking to life." The thought makes you yawn again. Maybe it's the gentle narration in your mind or the subtle vibration of untapped potential. Your flashlight beam catches tiny drill marks inside the copper tube, evidence of careful hollowing rather than crude hammering. Mainstream metallurgists note that such precision requires rotating tools, possibly bow drills, in use since 4000 BCE. Fringe enthusiasts counter that these tubes were cast around mandrels, hinting at lost ancient casting methods, rivaling modern foundries. You can't help but picture a pottery workshop doubling as a proto-fab lab complete with clay printers and soldering irons. You prop the jar on a soft cloth pad, padded with foam, modern care, for ancient relics, and step back to admire its simple elegance. A memory surfaces of the Great Pyramid's internal ramps from Section 4, where engineers conceal their scaffolding. Here the battery's inner workings hide in plain view, as if waiting for a curious host like you to unveil their secrets. The evening sun dips below the horizon, casting elongated shadows across the courtyard. You sip from your water bottle, the cool liquid grounding you in the present, even as you glimpse sparks of antiquity. You remember the Roman concrete's self-healing crystals in Section 5, and wonder if the Mesopotamian priests saw their jars as living devices, growing patina like living organisms. You plug the jar's electrodes into a data logger, watching the graph's gentle incline plotted across a screen, an electric echo of times long past. A stray spark leaps between contacts and you stifle a giggle. Prehistoric arc welding. Now there's a workshop safety hazard. You imagine ancient welders donning leather aprons and protective goggles carved from polished obsidian. A cricket chirps outside the sound, amplified in the desert stillness. You lean into the jar's opening, listening for static, or tiny pops, an auditory hallucination inspired by ASMR. The silence is thicker than the jar's residue, a reminder that many questions here lack satisfying answers. Historians still argue whether these batteries powered electrostatic experiments, medical treatments like pain relief via mild shocks, or purely ceremonial rituals invoking divine currents. Your eyelids flutter as you imagine priests applying voltage across metal amulets, chanting incantations to draw on the life force of electricity. You stifle a laugh at the image of them using sparking amulets as bedside nightlights, ancient mood lighting for the devout. You glance at your notebook filled with sketches of electrode configurations and scribbled hypotheses. Test alternative electrolytes, date juice, fermented camel milk, or crocodile dung elixirs. You grin at the callback to Section 1's sunscreen gag, crocodile fluids, remain the running joke in your field notes. Leaning back, you close your eyes momentarily, hearing only the data logger's soft whir and the distant gale of wind through the tent flaps. It's a lullaby of science, current resistance, and potential, all humming in sync. When you open your eyes, the jar sits serenely on its foam cradle, a testament to human curiosity reaching beyond simple pottery. The fringe speculations and mainstream analyses swirl in your mind like a potent cocktail, equal parts awe and exasperation at the mysteries left unsolved. You unplug the voltmeter, wrap the wires neatly, and place the jar back into its protective case. The desert night air greets you as you step outside, stars shimmering overhead like uncalibrated dial markers on the Antikythera's faceplate. Time to call it a night, both for you and these jars that may never fully reveal their spark. Your watch reads 4:22 a.m., definitely beyond reasonable bedtime. You pocket your notebook, stretch, and give the tent one last wistful glance. Tomorrow you might test new hypotheses, but tonight you'll let the Baghdad battery's soft hum lull you into dreams of ancient alchemists chasing lightning in clay. You wind the massive brass key into the tooth-saw cogs of the cathedral's astronomical clock, and you probably won't survive the dizzying spin of its 7-foot dial. Just kidding, but brace for whiplash. Mainstream fact: the Prague horloge, first installed in 1410 CE, is one of the oldest surviving medieval astronomical clocks in Europe, displaying zodiac positions, lunar phases, and even a calendar dial. Historians still argue whether it incorporated designs influenced by earlier Islamic timepieces or was an entirely independent European innovation. Your fingertips brush against iron-riveted gears that gleam like ancient coins, each cog meticulously fashioned by master blacksmiths under candlelight. A soft hum emanates from hidden chambers as weights descend, slowly powering the mechanism through gravity alone. You inhale the faint scent of burnt beeswax used to lubricate the bearings, an ASMR whisper of history and craftsmanship. Fringe lore suggests that clandestine monastic orders slipped alchemical formulas into the clock's engraved dials, encoding secret algorithms that controlled not just time, but the ebb and flow of spiritual energies. You stifle a sleepy giggle at the image of hooded monks chanting tick, tock, transmute in unison, calling it chronoalchemy. Maybe that explains the slight tremor in the gear's celestial magic, or just uneven masonry. You lean in closer, noticing miniature figurines poised to strike bells at hourly intervals. A skeleton wielding a scythe symbolizing death's inevitability, and a Turk shaking his head reminding medieval townsfolk of foreign threats. A playful thought crosses your mind: if you installed these in your living room, they'd shame your Roomba for being too quiet. Then again, an hourly skeleton strike might interrupt your nap schedule. No thanks. A gentle draft carries the distant toll of cathedral bells, mixing with your steady breathing like an unexpected ASMR mashup of Gregorian chant and your own snores. You smile, recalling the crocodile dung sunscreen from Section 1 and the donkey milk mortar of Section 5. This clock feels like the next track on our ancient engineering mixtape. Your beam catches a tiny inscription on the backplate: Master Hanush, 1490. Mainstream studies confirm that Jan Rouge, nicknamed Hanush, performed major restorations in the late 15th century, adding elaborate calendar functionality. Historians still argue whether Hanush was the original creator or simply a gifted restorer who enhanced a pre-existing mechanism. You rub your chin, pondering if you should assign half credit in your next research paper. Tough call. You gently turn a secondary dial, showing the sun's journey through the ecliptic. Its motion is so smooth you could mistake it for modern bearings, yet it's all wrought by hand-hammered and filed with medieval tools. Fringe enthusiasts claim that craftsmen used rudimentary diamond powders imported from India to polish the gear teeth for near-frictionless operation. You let out a sleepy chuckle: diamond polishing paste, because courtly timekeeping deserves nothing less. As you adjust the moon phase indicator, a silver orb rotates to reveal a waxing crescent. Mainstream fact: medieval clockmakers first achieved moon phase displays in the 13th century, but most were simplistic. The horloge's precision rivaled later Renaissance designs. Historians still argue whether earlier prototypes existed in monastic workshops, or if these features emerged only with a city-sponsored civic pride. Your elbow nudges a wooden railing and you hear the soft creak of oak underfoot. You imagine a guard rattling his keys. Stop leaning on the railing. If only they had installed a modern "do not lean" sign, though that might offend the aesthetic. A twitch of the skeleton figurine's arm startles you, and you yelp softly, half because of surprise and half because your eyelids are flirting with sleep. You trace the calendar disc engraved with the saints' feast days and medieval market schedules. It rotates once every year, aligning date markers under stained glass light that paints the faces of sleeping visitors in kaleidoscopic hues. Fringe tales suggest that secretive guilds used hidden levers to adjust the calendar disc, adding bonus feast days for guild celebrations. You smirk at the thought. Imagine a secret medieval mayhem day slipped into the calendar just for ale drinking. A distant drip echoes from a nearby alcove, water from roof leaks pooling near the clock's base. You sniff the damp air, detecting a hint of incense residue, likely from centuries of votive candles. This blend of wax and water produces a soothing undertone, like a spa ASMR track, except with possible structural damage. You stifle a yawn, remembering your own leaky faucet back home that you still haven't fixed. Your phone vibrates quietly in your pocket, no notifications, just the gentle hum echoing your pulse. You silence it, unwilling to break the ambience. You recall the Antikythera gears from Section 3 now spinning in your mind like a cosmic echo of this medieval marvel, two epochs separated by centuries, yet united in mechanical poetry. You lean forward to inspect the faint pitting on the brass surface where rooks of pigeons once nested. Mainstream conservation consigns that urban avian activity has worn down exposed clock faces over centuries, necessitating intricate restorations in the 19th century. Historians still argue whether the original clock mechanisms included pigeon-proofing features, tiny spikes, or secret grease traps, ingenious solutions to medieval bird control. Your breathing slows as you watch the minute hand crawl toward the hour. The skeleton figurine lifts its scythe in perfect synchronization, preparing to chime the bell. You brace yourself for the resonance. It resounds with a deep, sonorous thud that vibrates through your chest like a cosmic heartbeat. A fringe whisper claims these chimes once aligned with astrological events, sounding louder at solstices to signal portents. You smile louder. Chimes for summer equinox. Your neighborhood watch would love that feature. As the clock settles, you feel a wave of drowsiness wash over you, gentle, inevitable, like the setting sun. The interplay of weight-driven mechanics, carved wood, and polished brass creates a lullaby more effective than any bedtime playlist. You rub your eyes, recalling the Baghdad batteries, tiny sparks from Section 6. This clock's thunderous toll feels like electricity magnified into audible form. You step back, admiring the entire contraption framed by Gothic arches, stained glass filters, morning light in muted pastels, though here it's pre-dawn, so only moonlight and lanterns accentuate the dial. You imagine 15th century villagers gathering below, eyes wide with wonder, checking the time without asking, "Is it on my phone yet?" You stifle a laugh. Modern habits are strange indeed. Your watch reads 5:07 a.m., definitely past any reasonable bedtime. You lower the winding key, your fingers tingling from handling cold metal. You give the clock one last appreciative nod, as if signaling a silent good night. May your gears mesh smoothly until dawn. You step away down the echoing corridor, the soft click of floor stones underfoot marking your departure. The clock's gentle ticking recedes behind you, merging with your own heartbeat in a rhythmic duet. Outside the cathedral's spires pierce the twilight sky, guardians of time and sleepers alike. You stand beneath a lofty pavilion in Luoyang, the warm breeze rustling silk banners overhead. And you probably won't survive the suspense of waiting for an earthquake. This quiet, just kidding, but keep your helmet handy. Before you towers Chang Heng's famed seismoscope, a bronze vessel sculpted in 132 CE to detect tremors hundreds of miles away. Mainstream fact, this ingenious instrument contains 8 dragon heads around its circumference, each poised over a toad's mouth, and when seismic waves arrived, a hidden pendulum triggered a ball to drop into the correct toad's mouth. Clacking out an alert, historians still argue whether the ancillary internal mechanism used repeated pendulums or a single swinging mass with segmented catches. Your fingertips brush the cool bronze feeling, minute ridges where artisans chased decorative cloud motifs. A scent of aged metal mingles with the faint aroma of incense from the nearby temple, an ASMR-worthy fusion of devotion and engineering. Fringe lore claims Zhang Heng infused the bronze with powdered jade, believing its crystalline properties would enhance sensitivity. Imagine geologists today adding Swarovski crystals to their sensors. You suppress a sleepy chuckle, shiny seismometer, upgrades next level, bling for Richter scales. You peer into a tiny aperture at the top, catching a glint of the pendulum's pivot wheel, though the rest lies hidden. The pavilion's lantern light flickers, casting dancing shadows that make the dragon heads appear alive, ready to snarl at unseen tremors. A group of schoolchildren on a field trip gape at the instrument, whispering about how it's like Jurassic Park, but Chinese. You smile, recalling the medieval clock's skeleton figurine in Section 7. Both mechanisms warn of looming threats. Just one measures time and the other measures Earth's shudders. A soft creak comes from the wooden floorboards beneath you as you shift your weight. You recall crawling through the internal ramps of the Great Pyramid in Section 4. This pavilion feels equally clandestine, though thankfully without the risk of sand in your shoes. The gentle whoosh of a passing gust sounds like a hushed audience awaiting a dramatic reveal. Will the next earthquake be subtle or spectacular? You stifle a grin at the absurdity of waiting for continental plates to sign their attendance sheet. Beside you, your assistant holds a modern seismograph printout, its jagged lines charting microseisms from passing carts on cobblestone streets. You tap the digital display and say, "Snooze alarm off." Then you turn back to the bronze vessel, imagining ancient technicians in silk robes on night watch, listening for distant clangs instead of scrolling through smartphone notifications. Fringe theorists even speculate that Zhang Heng designed hidden alarm chimes that rang in local shrines, summoning priests to perform earthquake appeasement rituals, because nothing says calm down Earth like a chorus of monks chanting under a dragon's glare. You lean in to inspect one dragon head, its eye glinting like obsidian. Remember those laser-etched grooves from Section 2? This dragon snout might have rivaled those cuts for precision, albeit in a more ornamental style. The copper alloy around its jaw shows verdigris in fine feathery patterns, as if the dragon's size slowly corroded the metal. You trace the verdigris with your thumbnail, feeling the rough curves beneath your touch and picturing a prehistoric crocodile dung sunscreen experiment gone slightly sideways. Thankfully, no smelly ointments here. A distant toll of temple bells drifts through the courtyard, their reverberation mingling with your heartbeat. You remember the Antikythera mechanism's ticking gears from Section 3 and the Baghdad battery's faint hum in Section 6. This is the first time you're sensing an instrument without any visible motion. You hum softly, half asleep, half in awe, imagining the hidden pendulum swinging like a metronome for tectonic symphonies. Suddenly, a light tremor vibrates through the pavilion, a passing wagon's draft, or a subtle quake. Your elbow nudges the bronze rim, producing a soft ring like a dinner bell announcing seismographs to dinner. You chuckle at the thought of ancient engineers holding an awards ceremony, and the gong for most dramatic minor tremor goes to the Silk Road caravan. You catch a snort from a nearby scholar who's also fighting off drowsiness. You crouch to examine a small plaque at the base inscribed with Zhang Heng's dedication to Emperor An. Mainstream readings confirm the translated inscription praises the emperor's merit in commissioning scientific instruments. Yet some fringe historians argue the text contains veiled astrological warnings encoding prophecies of the dynastic upheaval tied to seismic events. You wink, imagining underground astrologers decoding hidden tremor predictions. Karma Tectonic Edition. Your stomach rumbles, reminding you of the leftover granola bar you stowed in your robe pocket. You break off a piece, the granola clusters crumbling like geological strata, and pop them into your mouth. The sweet nutty flavor feels incongruous in this solemn setting, yet somehow perfect modern snacks in an ancient seismic laboratory. You snap a mental photo, resisting the urge to Instagram. No hashtags in this sanctum, please. You rise and circle the seismoscope, noting how each dragon head aligns with the 8 cardinal and intercardinal directions, north, northeast, east, and so on. In your mind's eye, you see parallels with the Nazca lines from section 11, those giant geoglyphs aligned to celestial markers, ancient cartography at vastly different scales. Historians still argue whether artists drew those lines as runway guides for sky gods or as tumbleweed doodles. You giggle picturing tumbleweed hitting a giant geoglyph and triggering a seismic event. A soft breeze carries the distant aroma of mule stew from a vendor's stall outside the pavilion. You inhale deeply, craving savory warmth to chase away the slight chill creeping up your spine. You recall the Mediterranean sea spray and donkey milk mortar images of Section 5 engineering, delights often served with unexpected culinary sides. You pat your belly, grateful for both ancient ingenuity and modern snacks. Your hand drifts to your notebook, where you've sketched the dragons and toads, annotating hypothesized pivot mechanisms. Fringe speculation in your notes jokes about hidden sound chambers inside the vessel, amplifying tremor-generated infrasound into mystical chants. You grin at your own scribble earthquake karaoke ancient remix. A yawn slips out, and you realize the ASMR murmur of distant temple prayers mixes with the mental echo of dripping lab water from Section 4's pyramid passages, a perfect lullaby for geology enthusiasts. You lean your forehead gently against the cool pillar beside the seismoscope, letting the bronze vessel's stillness soak into your tired mind. There is something profoundly soothing about an apparatus that listens for Earth's whispers, rather than demanding attention like a buzzing smartphone. You close your eyes for a moment, inhaling the mixed scents of bronze incense and evening air. When you open them, the pavilion has grown darker. Lanterns glow warmer as dusk deepens. The courtyard beyond is hushed, waiting. You feel a comforting weight settle in your chest, knowing that somewhere unseen tremors may stir and be caught by this silent sentinel. No frantic alarms, just the poised readiness of 8 dragons waiting to deliver their gentle click. Your watch reads 6:12 a.m. Somehow, you've lost hours chasing tectonic echoes. You slip your notebook and granola crumbs into your pack, pat the seismoscope's bronze rim in silent thanks, and step back into the cool morning air. The desert of time stretches before you, dotted with marvels both mechanical and geological. As you depart, you cast one last glance at the dragon heads, imagining them snapping shut in perfect harmony to a distant rumble, an ancient drill sergeant's roll call for earthquakes. You smile, feeling both grounded and tremor alert, ready to drift into dreams of seismic dragons guarding the secrets of our restless planet. You stand barefoot on a warm sandy shore in the middle of the Pacific. The stars above, so sharp and luminous, they feel close enough to pluck from the sky, and you probably won't survive a solar canoe trip to Tahiti using only starlight. Just kidding, but you might want a snack first. The scent of salt wood and distant driftwood fires lingers in the air as you prepare to embark on one of history's greatest feats of navigation, Polynesian wayfinding. Mainstream fact: for centuries, Polynesians sailed thousands of miles across open ocean without compasses or maps, relying on star paths, swell patterns, bird behavior, and cloud shapes. Historians still argue whether such precise knowledge could be learned through casual apprenticeship or demanded lifelong commitment. You crouch by the side of a traditional double-hulled canoe carved from breadfruit tree trunks and lashed together with coconut fiber rope. A soft creak in the lashings sounds like the canoe stretching awake like an old dog rising from a nap. Fringe lore claims that some master navigators called PBO could feel subtle changes in ocean temperature through their feet to sense nearby islands. You wiggle your toes in the sand, imagining your own inner GPS recalibrating. Nope, still just sand. You scan the horizon where the sky's hue shifts slightly, giving away the hidden presence of an island beyond the curve of visibility. It's not magic, it's science. Light reflects differently off land masses than open ocean, causing cloud formations to hang lower above them. Mainstream wayfinders memorize these signs in oral chant cycles called kaula, storing entire archipelagos in song. You hum softly, imagining your Spotify playlist consisting of island coordinates and whale migration patterns. As you board the canoe, the woven mat underfoot is scratchy and slightly damp. A rhythmic creaking begins as the vessel rocks with the tide syncing perfectly with your heartbeat. You lie back against the hull, watching constellations emerge overhead like glowing tattoos on the night's skin. You remember the astronomical gears of the Antikythera mechanism from Section 3, and now you're following similar star paths with no gears, just pure memory and human instinct. You tap a wooden pointer toward Sirius, rising low in the east. The master navigator beside you nods approvingly and draws a line in the air toward Orion's belt. Fringe tales suggest that some ancient navigators used a handheld star compass, a mental grid where each constellation marked a bearing. You imagine the ultimate galaxy brain moment, no Wi-Fi, no GPS, just your eyeballs and a memory palace of stars. Your navigator dips a hand into the water, feeling the swells roll beneath the canoe. Each swell's angle reveals the direction of prevailing winds. You try it too immediately, overwhelmed like touching a piano and expecting to play Mozart. Historians still argue whether the wayfinders learned this sensitivity from early childhood or through structured, years-long mentorship under strict elders. Either way, you're still trying to tell the difference between swell and splash. The canoe glides forward, silent but purposeful. You trail your fingers through the water, the cool sensation keeping you awake as your eyes grow heavy with starlight. You snack on dried banana chips, sweeter than expected, and think of Roman concrete, Section 5, which survives through chemistry. Here, it's knowledge that survives passed through generations with 0 written records. A seabird circles above its wings, slicing the moonlight. Your navigator watches it closely. It's a manu or ku, or white tern, known to return to land each night. The canoe gently shifts direction. Mainstream wayfinding schools in Micronesia and Hawaii still teach this method today, rebuilding ancient traditions that once spanned half the globe. Fringe whispers tell of legendary ghost islands, visible only to true navigators on rare nights when the sea glows blue. You smile, half lulled by the soft slosh of the sea, half convinced you'll spot Atlantis before morning. You spot a rising cluster of stars, Pleiades, the Seven Sisters, blinking into view like stage lights. They mark seasonal changes and were considered crucial timing cues for planting, sailing, and even mourning. Your navigator sings softly under his breath, a chant that counts off each island on a remembered journey. The melody is slow and hypnotic, each note tied to geography like musical breadcrumbs. You fight the urge to drift off mid-verse. There's a difference between bedtime story and mid-ocean nap. Suddenly the canoe tilts subtly. Your navigator shifts his stance, sensing a current change. You recall the internal ramps of the Great Pyramid Section 4 and the hidden mechanics of medieval clocks. Section 7, but this is the first system with no moving parts at all, just sea stars and someone who knows how to listen. Historians still argue whether this skill set is neurological, developed by brain structures adapting to decades of non-visual spatial awareness. You wonder if your own mind could ever stretch wide enough to hold an ocean in it. The breeze carries a faint, warm scent of taro and salt pork, your imagination or a nearby island's kitchen welcoming you. Either way, your stomach grumbles. You nibble another banana chip and stare ahead, watching the ocean gently gleam with bioluminescent plankton like stardust spilled onto water. Fringe beliefs claim that some navigators used phosphorescence trails to track migrating fish or shifting ocean temperatures, turning marine biology into another kind of map. A distant glow now rises on the horizon, not starlight, but firelight. The navigator whispers, "Land," and you squint until you see it, a thin line of darkness breaking the sea's curve. You feel it in your bones too, not just sight, but a knowing. You feel strangely proud, like you helped a little, even if you mostly snacked and stared at the stars. You turn back and watch the stars slowly shift, the constellations you once used as guides now dancing behind you in farewell. The canoe slows, riding the shallower swells with grace. You remember the copper and iron jars from Section 6 and the dragon-headed seismoscope of Section 8. Those inventions measured energy. This one measures experience, memory, rhythm. You realize the Polynesian wayfinder is a kind of human seismograph, tuned precise and beautifully quiet. Your eyes grow heavy as the canoe drifts to a stop in the lagoon. You lie back against the side waves, lapping gently at your feet. The navigator begins a closing chant, a lullaby to the sea, thanking it for safe passage. You let the chant carry you, eyelids finally surrendering to sleep. The sky above now full of familiar guides. Your watch still dry in your pocket somehow reads 6:58 a.m. just in time to say good morning and good night. You smile in the dark, knowing that somewhere between moonlight and muscle memory, you just crossed an ocean guided only by what the ancestors knew. You're standing in the echoing ruins of a Greco-Roman temple, the scent of weathered marble and olive groves swirling in the afternoon breeze, and you probably won't survive making eye contact with a mechanical goddess. Just kidding, but she does blink. Before you stands a reconstructed automaton, a life-size statue of Athena, rumored to have once bowed, extended her hand and offered oil when worshippers approached. Mainstream fact, ancient texts by Hero of Alexandria describe dozens of such machines, self-opening doors, singing birds, and even coin-operated holy water dispensers, all powered by weights, counterbalances, steam or hydraulics. Historians still argue whether these machines were widespread public spectacles or rare temple curiosities reserved for elite ritual. You step closer, the marble floor cool underfoot, and run your fingers along the bronze plating on a nearby pedestal. Its surface bears the faint engraving of a dove in flight, symbol of Aphrodite, or maybe just an ancient engineer's flourish. The mechanism's joints are exposed, revealing a system of thin rods, pulleys, and pivot gears, cleverly hidden behind ornamentation. Fringe lore claims that some temples employed full mechanical choirs, rows of statues that moved and sang in sync, giving the impression of divine voices echoing through the colonnades. You smirk at the mental image of a statue flash mob breaking into a synchronized hymn. You crouch by the base, where a stone basin would have once collected offerings. Inside it, rusted valves hint at a fluid reservoir. A side compartment houses a series of hollow tubes connected to pressure chambers. Hero's own designs, preserved in the pneumatica, describe machines triggered by fire or steam, where heated air expanded to push water, rotate wheels or flap wings. Fringe enthusiasts propose that some temples used concealed steam cannons for theatrical thunder effects, because nothing says godly presence like a mechanical roar. A shaft of sunlight cuts through a broken frieze above, lighting up the automaton's face. You swear the pupil dilates, probably just a trick of light, but you step back anyway. The metallic gaze is uncanny, lifelike, maybe even too lifelike. Remember the skeleton that chimed the clock in Section 7. This is like her divine cousin, polished and programmed to grace worshippers with awe. Historians still argue whether such effects were created for religious manipulation or sheer entertainment. You wander toward a smaller automaton perched beside a plinth. A golden bird wings, half spread, its belly filled with gears and pipes. Mainstream records tell us of mechanical birds that chirped and fluttered at the touch of a button using air pushed through tuned pipes, not unlike a pipe organ. Fringe speculation adds flair. Some claim birds could mimic speech like early versions of talking toys. You lean in close, whisper hello, and are met with silence. But you do hear a faint hiss, air moving through corroded tubing, and that's almost eerie enough. You sit on a marble bench and unwrap a fig bar from your pack, the sweet scent grounding you. The soft rustle of the wrapper feels almost disrespectful among so many quiet machines. But as you munch, you imagine ancient temple attendants feeding the automata olives and oils like pets. Time to oil the goddess again, she's squeaking at visitors. You stifle a sleepy laugh, crumbs caught in your lip. Behind the columns, a larger contraption looms, a rolling chariot, once powered by a hidden falling weight. As the weight descended through a concealed tube, it drove a gear train that pushed the wheels forward. Hero's notes even describe a programmable cart. Yes, programmable, using rope knots and pegs to determine how it turned. Historians still argue whether this qualifies as the world's first robot or just a glorified parade float. You lean your head against a fluted pillar, whispering, "Alexa, roll into battle," and close your eyes for a second too long. A breeze ruffles your hair, scented with rosemary and warm stone. You open your eyes to see the automaton's shadow stretched long across the floor, mimicking a bow. You know it didn't move, but it feels like it might have. There's something disarming about these machines. Unlike the cold logic of modern robotics, they were designed with flair, drama, even humor. They weren't just tools, they were stories in motion. You stretch and stand, brushing fig crumbs from your lap. The sun is dipping lower now, casting gold light through the colonnades. You think back to the internal ramps of the Great Pyramid. Section 4, the underwater durability of Roman concrete. Section 5 and the Baghdad batteries whisper of current Section 6. Those were systems of utility. But automata. There's something more playful, more human. You remember the Polynesian navigators' starlit voyage from Section 9. Those sailors rid the sea and sky with memory and instinct. These ancient engineers, they encoded their knowledge in gears and valves, choreographing mechanics to mirror life. Fringe writers even theorize that temples used automata to simulate divine judgment. Imagine a statue of Zeus that nodded yes or no based on weighted responses. Should we sacrifice the goat? Clunk Zeus says yes. Talk about divine delegation. As twilight falls, torches flicker to life in the exhibit hall, casting warm shadows that ripple across the marble floor. You walk slowly among the still figures, each one frozen mid-motion, as if caught in a dream they've been dreaming for 2,000 years. A lion-headed automaton stands in one corner, its chest plate emblazoned with a sun disk, its internal bellows long rusted. You wonder if once upon a time it roared. Your flashlight beam lands on a fragment of Hero's own blueprints mounted beneath glass. The lines are delicate, purposeful. One gear connects to another, not unlike the thought that connects now to then. You blink slowly, mind foggy with sleep and wonder. There's a reason these marvels seem magical. They blur the line between human creation and divine mimicry. You step toward the exit, yawning as the temple doors creak closed behind you. Outside, the air is cooler now, perfumed with evening jasmine. Your legs are tired, your thoughts heavy. You glance back once more, half expecting the automaton to wave goodbye. She doesn't. But you're still not convinced she couldn't. Your watch glows faintly, 7:29 a.m. Another hour, another mystery tucked into your mental museum. And as you step down the stone path into the waking day, you realize these ancient machines weren't just marvels of their time. They were stories made of gears. You hover above a wide dusty plain in southern Peru, the wind barely touching your face as the drone camera you're monitoring captures the view below, and you probably won't survive trying to draw a 300-foot hummingbird with your eyes closed. Just kidding, but your GPS better be locked in. Beneath you stretch the Nazca lines, massive geoglyphs etched into the desert crust, covering over 50 square miles with straight lines, animal figures, and spirals so precise they'd make any geometry teacher shed a proud tear. Mainstream fact: the lines were created between 500 BCE and 500 CE by removing dark rocks to reveal the pale clay underneath. Historians still argue whether the designs served as ritual pathways, astronomical calendars, or messages to sky gods. The drone buzzes softly beside your ear as you trace the outline of the famous monkey geoglyph on your tablet screen. Its looping tail coils with mathematical grace, an ancient flourish carved without the benefit of drones, GPS, or even ladders. You mutter, how did they do this? The question everyone asks by instinct. Fringe enthusiasts jump in with wild theories, alien landing strips, prehistoric airfields, or even telepathic ground planning sessions under the influence of cactus juice. You smile sleepily, amused by the idea of ancient surveyors holding hands in a trance chanting, "Draw me a spider." Your guide, a local archaeologist, explains the traditional method: long wooden stakes and ropes used to plot massive grids, just like modern chalking a football field. You remember the straight grooves from section 2 and realize same principle, just supersized. You glance down again, the lines still shimmer faintly in the heat, seemingly immune to erosion. Mainstream studies reveal that the dry climate and minimal rainfall preserve them. Historians still argue whether such preservation was intended or an incredible coincidence. Your boots crunch against the desert crust as you step toward the ground-level starting point of a line that stretches over 9 miles. It's so straight you half expect it to beep like a runway at LAX. You bend down, brushing your fingers across the shallow groove, and feel nothing fancy, just a groove in the dirt. And yet it's lasted for over a millennium. Fringe theory claims quartz beneath the desert reacts electromagnetically, with the stars guiding the line makers like an invisible blueprint. You stifle a laugh, imagining them checking constellation signals like you'd check cell reception, 1 bar over Pegasus, perfect. You sip from your water bottle and glance around the plain. Vultures wheel lazily overhead. The heat distorts the horizon, making distant hills shimmer like mirages. You remember the Polynesian star paths from section 9 and wonder if these desert lines also led somewhere across a different kind of ocean. A place not of water, but of sky and myth. You walk carefully toward the spider geoglyph, 150 feet across, legs extended in precise symmetry. You recall that spider species depicted here is believed by some entomologists to exist only in the Amazon rainforest, hundreds of miles away. Historians still argue whether this reflects trade route, knowledge, religious pilgrimage patterns, or just a really creative desert doodler. Fringe writers even suggest the lines were only visible in full from hot air balloons based on ancient pottery showing figures holding what look like balloon sacks. You smirk. Next up, Nazca Air's scenic tour, peanuts optional. Your drone captures a high shot, the image rendering on your screen. The lines are even more striking from above, bold, unmistakable, like signatures scrawled across a silent canvas. You pan across a runway glyph, 2 perfectly parallel lines, half a mile long. You remember the precision of the Antikythera gears in section 3 and think, this is that but horizontal. One was celestial timekeeping. This may be celestial messaging. The wind kicks up slightly, carrying dust and a faint herbal aroma from your guide's coca tea flask. You take a sip, bitter, earthy, grounding. In the distance, a condor geoglyph spreads its massive wings, a stylized echo of the bird you saw earlier in the sky. It measures over 400 feet long. Some scholars suggest these animal figures marked sacred ground or water sources. Others think they were ceremonial processional routes walked in silence under the baking sun. You stare down the line, imagining robed figures, pacing solemnly, footfalls, quiet each step a prayer. Fringe theorists have more colorful ideas. Some say the lines were part of a giant irrigation ritual meant to summon rain by mimicking river paths from the gods' perspective. You chuckle, picturing sky spirits peeking down and saying, "Oh, good, they drew a whale again. Time to send rain." You stifle a yawn, the kind that comes after too much sun, too much wind, and too much mystery. The heat presses against your temples like a warm, sandy pillow. You sit on a rock, the sun behind you, now casting long shadows across the lines. You take out your notebook and sketch a simplified hummingbird, labeling each wing's length, jotting speculative functions, ritual path, celestial tracker, party planning, grid. You add a silly note at the bottom or ancient prank to confuse future tourists. You remember the mechanical temple birds from section 10 and laugh softly. Those sang these, "Stay still forever," yet both speak across time in their own quiet language. A sort of visual ASMR if such a thing exists. As the sun begins to dip toward the mountains, the desert turns gold and the shadows deepen. You stand slowly, brushing sand off your knees, and glance one last time at the hummingbird, its beak pointing unerringly northeast. Your guide hums a local tune, a lullaby passed down from those who once walked these lines barefoot. You smile knowing you've walked just a few feet of a design that spans miles and centuries. The Nazca didn't build machines or concrete, they built memory into the ground. Like the Polynesian wayfinders reading stars or the Roman engineers shaping water, the Nazca left behind something to be followed, not explained. Your watch glows 8:41 a.m. One more puzzle tucked behind your eyes as your brain slows to a dreamier pace. You head toward camp shoes filled with dust, heart filled with quiet awe, and just enough energy to whisper, "Good job, Spider." You find yourself rocking gently aboard a Viking longship, the cold wind slicing across the fjord and your fingers gripping the carved wooden rail tight enough to remind you that you probably won't survive a North Sea storm in your pajamas. Just kidding, but wool socks wouldn't hurt. Beneath your feet, the ship creaks with the same eerie rhythm as a lullaby sung by the ocean herself. Mainstream fact: Viking longships developed between the 9th and 13th centuries were clinker-built vessels with overlapping planks, shallow keels and symmetrical bows, allowing them to sail swiftly forward or backward without turning around. Historians still argue whether this design evolved purely through trial and error or through a formal tradition of maritime engineering passed from shipwright to shipwright. Your boots slip slightly on the salt-worn deck as you pace toward the mast. The sail, woven from tightly spun wool and sometimes reinforced with leather, flutters softly above. You reach out to touch the wood of the mast, warm from sunlight, oiled and scarred by countless voyages. Fringe theorists whisper that some Viking ships were treated with a secret resin made from pine sap, whale oil, and fermented seaweed, which enhanced waterproofing. You smirk, picturing a Norse sailor bottling ship slime number 3 and selling it at the medieval equivalent of a hardware store. You move aft past the rowers' benches, each perfectly spaced to avoid tangled oars. The symmetry is elegant, almost surgical. Your fingers trace the joinery between the planks. Iron rivets, driven through overlapping edges, form a resilient hull, yet the ship remains light enough to be carried overland. Mainstream archaeologists have marveled that these longships had no central keel, just a strong spine called the keelson, making them flexible in high seas. Historians still argue whether this flexibility was a safety feature or a byproduct of their rapid construction process. You crouch and peer through the longship's ribs, sunlight filtering through cracks between planks in thin silver lines. The interior feels organic, alive. You remember the bird-headed automata of Section 10 and the hummingbird geoglyph of Section 11. Those were still frozen in time. But this ship, it moves, it breathes. Even moored, it hums with purpose. You unwrap a smoked fish snack from your pack, salty, chewy, and a little bit bold for breakfast. You bite down and smile. Fringe enthusiasts often claim Vikings chewed on kelp while sailing, not just for nutrients, but to measure humidity by how soft the kelp got. You glance at your fish and wonder if your breakfast could double as a weather sensor. Too salty, storm's coming. The helmsman's station catches your eye, just a simple steering oar mounted starboard. You kneel beside it, examining the notches along the tiller. Some scholars believe these were measurement guides showing how much torque could be safely applied without snapping the oar. Historians still argue whether the steering techniques varied significantly between fjord travel and open sea raids. You imagine a young Viking shouting 10 notches starboard as seagulls scatter overhead. You turn toward the figurehead, a fierce serpent with eyes narrowed in mid-snarl, designed not just to intimidate enemies, but to frighten away sea monsters, or so they claimed. Fringed tales abound of figureheads carved from blessed trees, struck by lightning infused with protection spells. You stifle a sleepy laugh. Lightning-scarred wood, dragon-shaped prow, and waterproof fish snacks. Vikings were the original survival influences. The longship rocks, gently lulling you into a rhythm. You close your eyes and imagine the scene centuries ago, a crew of 30 men rowing in perfect unison, muscles, taut songs echoing against the wind. Their chants blend with a rhythmic splash of oars, part timekeeper, part war cry. You crack your eyes open, half expecting them to appear like ghosts on this replica deck. Your guide, a maritime historian, gestures toward the sail, now catching just enough breeze to shift the ship gently sideways. You recall that Viking sails weren't just functional, they were status symbols. Wealthy jarls dyed theirs crimson with a madder root and trimmed them with gold thread. Fringe rumors speak of sails that bore coded runes, visible only under certain light, guiding the ship toward hidden shores. You peer at the fabric above just in case. Nope, just wool and seagull stains. You check your phone out of habit, still no service. Not that you need it. The sky is your compass now. You scan the horizon. There's the North Star faint even in daylight. Vikings used a tool called a sunstone, a polarized crystal like Iceland spar, to locate the sun's position through cloud cover. Mainstream fact, this trick works even on overcast days, and some modern researchers have replicated it successfully. Historians still argue whether every ship carried one or just the best captains. Either way, you kind of want one now, especially if it comes on a keychain. The boat bumps softly against its mooring post, a reminder that this is a museum dock, not a fjord port. You lean over the edge and watch fish dart through the shallow water below. You remember the Polynesian canoe in Section 9 and how it sliced through the Pacific by instinct. This longship feels like its distant cousin, built for colder waters, but with the same soul of motion. A gust tugs your jacket as you stand and stretch. The ship creaks again as if saying, "Time to go, landwalker." You brush fish crumbs from your lap, tug your notebook from your pack, and sketch a rough outline of the hull, long, lean, and symmetrical. You jot a note beside it, "Speedboat of the past with way cooler branding." You step off the ship boots, hitting the dock with a thunk. Behind you, the dragon-headed prow still points toward the open sea, daring you to try again in winter. You glance at your watch, 9:22 a.m. The longship is still here, still ready, still whispering secrets of balance, efficiency, and fearless ambition. You walk down the pier, slowly letting the cold air sting your cheeks awake. The sail flutters once more, a final wave goodbye. You won't forget the feeling of standing aboard a vessel that helped shape the world, not through comfort, but through speed, simplicity, and sheer courage. You're wading through a forgotten canyon in Petra, Jordan, the stone walls glowing warm coral in the morning light, and you probably won't survive dropping your water bottle in this heat. Just kidding, but dehydration is the ancient enemy here. As you pass beneath an arch of rose-colored sandstone, your eyes land on a crumbling aqueduct carved right into the canyon wall. It doesn't look like much, just a shallow channel, but you know better now. You're standing in one of the most sophisticated hydraulic systems of the ancient world. Mainstream fact: the Nabateans built vast networks of water channels, cisterns, and pressure regulators to supply their desert capital with water year-round. Historians still argue whether they learned their engineering from earlier Mesopotamian systems or developed it independently in response to extreme desert conditions. You trail your fingers along the smooth channel groove, still slightly slick with ancient mineral buildup. Fringe theory says some Nabatean engineers used beeswax plugs in the pipeline joints, which, if true, would be one of the earliest examples of controlled pressure regulation in plumbing. You imagine ancient plumbers carrying pouches of wax and whispering, "This one's a two-swarm job." You snort softly, then reach for your canteen and take a long swig, toasting them in silence. The canyon narrows, and you spot a junction where two water lines merge, each with a subtle slope, a gradient so precise it rivals modern urban water infrastructure. Mainstream archaeologists estimate that these channels maintained a consistent grade of about 2 to 4%, allowing water to flow gently without erosion. Historians still argue whether the builders used weighted plumb lines or sightline alignment using polished obsidian mirrors. Either way, your GPS app looks primitive in comparison. A little farther on, you come upon a reservoir, now dry, but the darkened line along its interior shows where water once pooled. It's massive, capable of holding tens of thousands of gallons. Nabatean engineers even designed overflow chambers to reduce pressure on the main channels. Fringe speculation holds that some basins doubled as echo chambers during rituals, turning flowing water into a sacred symphony. You try humming into the empty tank. Your voice bounces back, spooky and sleep-inducing. You laugh to yourself, imagining priests in sandals staging water-themed ASMR ceremonies. You climb up a ledge beside a partially buried pipe. It's made of ceramic, its pieces locked together like puzzle joints. You crouch and peer inside. There's still a tiny trickle of water seeping through, as if the desert is reluctant to fully let go. You remember the Roman harbor concrete in Section 5 and wonder if someone in Petra once met someone in Ostia and they swapped notes over lunch. You scribble into your notebook, Hydraulic Summit 2000 years BCE, catering by figs. A faint breeze stirs the dust, revealing inscriptions etched beside the channel. Notations, inventory marks, fringe. Writers say these were unit indicators, showing how many jugs of water passed each checkpoint daily. You squint and imagine a water accountant, stylus behind one ear, grumbling about a leak in the east line again. Even in the ancient world, bureaucracy found a way. You pause to eat a handful of dried apricots, their tartness grounding you in the present. You wash them down with another gulp of water, then sit for a while on the reservoir's stone rim. The silence is heavy, but not oppressive. It feels purposeful, like the stillness right before a city wakes. You think back to the seismoscope's breathless dragons in Section 8, the Nazca Line's sprawling paths in Section 11, and the Polynesian canoe. Reading wave whispers in Section 9. Petra fits right in another system that listens instead of speaks. Eventually, you rise and enter a side canyon where a tunnel has collapsed, revealing cross-sections of old piping. It's beautiful terracotta, wrapped in layers of plant fiber and sealed with lime mortar. Mainstream studies have confirmed this combination reduced leaks and resisted heat expansion. Historians still argue whether similar techniques were used in Jerusalem's underground channels and adapted to mountain versus desert terrains. A metal glint catches your eye, an old valve piece, bronze and corroded, sticking out from the rubble. You kneel beside it, brushing dust away with your sleeve. The knob still turns slightly. You twist it carefully, listening to the faint creak of ancient engineering waking from its slumber. Fringe theorists call Petra's system hydraulic whispering, as if the city never stopped breathing, just slowed down to sleep. You nod slowly. You feel that. You walk the length of a switchback channel that once led to ceremonial gardens. Yes, gardens in the middle of a desert canyon. Archaeological evidence points to complex water redistribution paths that fed fruit trees, grapevines, and even fountains. Fringe stories claim one garden grew plants in a sacred pattern matching star constellations, combining agricultural science and celestial reverence. You smile, imagining a priest shouting, "I need another bucket for Orion's belt," while gardeners roll their eyes behind fig bushes. At the top of the switchback, you sit beneath a weather-worn niche where a statue once stood. The water channel ends here, a carved stone spout shaped like a lion's mouth. Nothing flows now, but you can picture it, the roar of rushing water echoing through canyon walls, feeding the city below. You remember the Antikythera's gears turning Section 3 and the Viking longship cutting through waves. Section 12, this was Petra's heartbeat, its pulse system. Your eyelids feel heavy. You lie back on the sandstone ledge and watch the clouds drift above, just a few wisps, as if even the sky respects the slow rhythm of Petra's silence. You close your eyes for a second just to blink and feel the weight of centuries settle around you like a soft blanket. Your watch reads 10:15 a.m. The heat is rising, but the shade here holds. You stretch once, stand slowly, and begin the walk back toward the city's sandstone gates. Behind you, the lion's mouth watches, quiet and dry, but still proud. You kneel on a stone floor inside a quiet museum gallery, staring at the rippling grain of a blade that looks more like liquid fire than forged metal, and you probably won't survive touching its edge. Just kidding, but your fingerprints might feel personally attacked. This is Damascus steel, the legendary metal of Middle Eastern swordsmiths, known for its strength, flexibility, and hypnotic water-like patterns. Mainstream fact, true. Damascus blades were forged from high-carbon wood steel imported from India and Sri Lanka, containing carbon nanostructures that gave them extraordinary durability. Historians still argue whether the original process was intentionally scientific or a happy metallurgical accident refined over centuries. You lean in close eyes, scanning the delicate banding like fingerprints pressed into steel. The wavy lines shimmer under the gallery light, revealing alternating layers of iron carbide and softer steel. Fringe theories suggest that some blacksmiths encoded patterns into the blades not just for beauty, but to serve as maker's marks, battle prayers, or even encrypted blueprints. You trace one swirl with your finger, whispering, "Art that slices." Beside the blade lies a broken crucible, its interior glazed black from intense heat. Mainstream archaeologists believe these were used in airtight smelting processes to preserve the carbon needed for true Damascus strength. But some scholars think the shapes of the crucibles varied depending on the smith's guild, each with their own recipe, guarded like a dragon horde. You picture a group of scowling apprentices chanting, "Thou shalt not share the crucible curve," as part of their oath. The blade before you curves gently like a crescent moon. You remember the temple automata from Section 10 and the self-pouring Baghdad batteries from Section 6. Mechanical wonders, yes, but this blade, it's something more personal. It lives in your hand. A tool, a weapon, a signature. You pick up the replica beside it, the modern version, dull and clean, its weight oddly lifeless. You set it down again respectfully. A nearby plaque explains that true Damascus steel production faded from memory around the 18th century, possibly due to disrupted trade routes, depleted ore sources, or even the suppression of techniques by guild elites fearing industrial redundancy. Fringe lore goes further. Some whisper that alchemists deliberately buried the secret to prevent it from falling into the hands of conquerors. Historians still argue whether this was metallurgical entropy or intentional vanishing. Either way, the mystery stuck. You munch on a date from your pocket, a sticky reward for making it through a long morning, and gaze at the replica swords arranged on the wall. One is chipped, another warped. None match the perfection of the central blade. You wonder if even the blacksmith knew, in that moment of final tempering, that he was creating something no one would ever quite replicate again. An adjacent display features microscopic photos of Wootz ingots, tiny spheres, and whirls of carbon matrix structures. Nanotechnology. Kind of. Mainstream metallurgists have discovered that some ancient smiths intuitively understood phase transitions between cementite and pearlite in the steel's grain. Fringe thinkers call it ancestral nanoscience. Your grin sounds like a good name for a band. You remember the whispering desert canals of Petra Section 13, the Nazca lines you followed across the Peruvian plain, Section 11, and the Viking ship that creaked like an old war song, Section 12. This blade is part of the same long story, humans reaching beyond survival toward mastery. Not just making, but perfecting. The room is quiet now. Other visitors have trickled out, leaving only you, the blade, and the faint sound of HVAC humming overhead like a distant forge bellows. You sketch the blade in your notebook, trying to capture the subtle waves, not straight, not chaotic, balanced, controlled, alive. You scribble underneath steel with a soul. You notice a faded diagram on the wall showing possible chemical compositions. One notes trace amounts of vanadium and molybdenum, rare in the region, possibly traded across thousands of miles. Historians still argue whether these elements were intentional alloys or accidental gifts from unknown mines. You recall the copper in the Baghdad batteries, the volcanic ash in Roman cement, and smile sometimes nature leaves clues inside its gifts. The museum lights dim slightly for the afternoon transition. You rest your head against the display glass for a moment, eyes heavy. You imagine a blacksmith's shop lit by coals and quiet resolve, hammer striking metal again and again until it hums like a song. You hear it faintly now, each clang echoing not just in your ears but in your spine. Fringe stories speak of Damascus blades that never dulled, that could slice a silk scarf in midair or cleave stone in two. You don't need proof. Standing here watching the light dance across the blade's grain, you believe it anyway. You stretch eyes, misty from staring too long. The weight of history feels warm on your shoulders like a smith's apron. You check your watch, 11:08 a.m. You've been here longer than expected, but it's fine. Damascus time doesn't tick. It rings sharp and clear in every whisper of steel. You step toward the exit slowly, heart still echoing the rhythm of hammer and flame. One last glance, one last nod. The blade stays behind, eternal, elegant, and in its silence louder than anything you've heard all day. You sit cross-legged in a quiet library archive, sunlight trickling through stained glass windows, and you probably won't survive trying to explain all the ancient tech you've seen without sounding like a time-traveling conspiracy theorist. Just kidding, but your brain is buzzing like a power grid. Around you are scrolls, sketches, digital blueprints, and your dog-eared notebook now overflowing with drawings of gears, boats, grooves, and God knows what else. This is the part of the journey where the past echoes forward and the present starts listening. You flip back through your notes, obsidian blades, sonic grooves, stargazing Polynesians, steam-driven temple doors, humming seismoscopes, singing statues, and steel with a soul. You feel a strange calm settle over you. Mainstream fact, modern engineers and material scientists are already studying these ancient marvels, not just for history's sake, but to revive forgotten solutions. From the self-healing chemistry in Roman concrete to the hydrodynamics of Viking ships, echoes of the past are being reverse-engineered into the architecture and transportation of the future. You glance up as a librarian wheels past, completely unfazed, by the fact that your table looks like an inventor's fever dream. Fringe thinkers go a step further, suggesting our greatest innovations aren't new at all, just rediscoveries. That history moves in spirals, not lines. You close your eyes and imagine a future drone designed with aerodynamic principles borrowed from Nazca lines, or a modern robot using automaton logic from Hero of Alexandria. Sounds absurd. Maybe, but then again, so did flying once. You flip to the last page of your notebook where you've drawn a rough timeline. Not by dates, but by principles, balance, resonance, durability, elegance. You connect dots across millennia with a looping arrow. One line reaches from Petra's water channels to modern irrigation apps. Another arcs from the Baghdad battery to biodegradable sensors in development today. Historians still argue whether these connections are coincidence or legacy. You argue that the truth, like all good technology, is layered. Outside birds chirp and a breeze rustles the hedges, but in your mind you're still deep in the gears of the Antikythera, listening to moon dials tick. You recall the weight of the Viking helm in your hands, the shimmer of Damascus steel, the soft clang of a dragon-headed seismoscope whispering of earthquakes. All of it real, all of it forgotten, and all of it somehow still waiting. You tap your pen against your teeth, then underline a single phrase in your notes, when the past surpasses the present. That's been the pattern, hasn't it? Not every time, but enough to feel it. That strange humility you get from realizing people 2,000 years ago solved problems we are still puzzling over, with no calculators, no spreadsheets, just persistence, intuition, and maybe a few divine hunches. You remember the Polynesian star charts from Section 9 held not in paper, but in memory, chanted aloud across generations. You remember the Great Pyramid's uncanny geometry, the Nazca builders, walking lines no one could see from the ground, the Roman engineers who poured concrete that hardened underwater and kept hardening for centuries. You recall the mechanical monk-like figures that opened temple doors and birds that chirped thanks to a hidden puff of air. The more you think about it, the clearer it gets. The past isn't dead, it's coded. A soft chime signals the top of the hour. Your eyes land on a quote carved into the far wall. It reads, "The future is built from the ruins of memory." You close your notebook slowly. The weight of the pages feels heavier now, but in a good way. Like they've absorbed not just your thoughts, but every buried whisper of water channels, copper coils and lunar dials. You feel grounded, and just a little electrified. You rise and stretch, letting your limbs remember the present moment. A ray of light catches the corner of a glass display case behind you. Inside a replica of the Antikythera mechanism, full circle, gears locked in a still loop. You grin, then whisper, half to yourself, half to the mechanism, "Don't worry, we didn't forget." Not completely. Your watch reads 12:03 p.m. You blink once, then step quietly out of the archive into the sunlight. And for the first time in hours, you don't feel like you've been studying ruins. You feel like you've been gathering blueprints.